हेलो स्टूडेंट्स, कैसी तैयारी चल रही है? हाउ आर यू? वेलकम टू माय चैनल. If you have not subscribed my channel yet, please subscribe by pressing the subscribe button. Today I shall discuss one important chapter in inorganic chemistry, that is periodic properties. In periodic properties we study mainly four properties. First is atomic radii or ionic radii and its variation along groups and periods in periodic table. Second is ionization potential and its variation around periods and groups in periodic table. Third is electron affinity and last one is electronegativity. The first periodic property I shall study is periodic variation of atomic and ionic radii. The first periodic property which we shall study here is atomic or ionic radii and their variations in periodic table along periods and groups. Atomic or ionic radii may be defined as the distance between the nucleus of an atom and the outermost shell of electrons. Atomic radius is defined as the distance between the nucleus of an atom and the outermost shell of electrons. For example, if we take an atom, this is the nucleus, if it is the nucleus, and these are the cells. This is the nucleus in which neutrons and protons are present and electrons are revolving in the orbits. Then this distance is known as atomic radii. This distance is known as atomic radii. The distance between the nucleus of an atom and outermost shell of electrons is known as atomic and ionic radii in case of ions. But this distance is very small and atoms are not present as individual particles, so direct measurement of atomic or ionic radii is not possible. We cannot measure directly atomic or ionic radii. These distances are measured by indirect method, indirect way. In case of covalent molecules, the distance between the nucleus of two bonded atoms is known as internuclear distance. This is known as internuclear distance. If two atoms are bonded covalently, then the distance between the two neighboring atoms is known as internuclear distances. Similarly, in case of metallic crystals, this distance between the two neighboring metal atoms is known as interionic distances. By measuring internuclear distances or interionic distances, we can determine atomic radii or ionic radii. These distances are so small, so they are measured by X-ray diffraction technique. They can be measured by X-ray diffraction technique or electron diffraction technique. These distances are of the order angstrom, which is equal to 10 to the power minus 10 meter. So they are measured by X-ray diffraction or electron diffraction methods. Now the atomic radii can be further classified into three types. First one is covalent radii or covalent radius. The covalent radius is defined as one half of the distance between the two like atoms bonded together by a single covalent bond. Thus, covalent radii is essentially single bond covalent radii. For example, if we take diatomic homonuclear molecule in which two like atoms A and A are bonded together by single covalent bond, and if the distance between the nucleus of two bonded atoms is d, if this distance is d, then covalent radii is equal to d by 2. The covalent radii is equal to internuclear distance divided by 2. This is the case of the non-metals in which covalent bond is formed. Next is metallic radii. The second classification of atomic radii is metallic radii or crystal radii. It is also known as crystal radii since most of the metals exist in the form of crystal lattice. Metallic radii may be defined as 1/2 of the distance between the two neighboring atoms of a metal in closed packed structure in which metal exhibits coordination number 12. This is the 1/2 of the distance between the two neighboring atoms of a metallic crystal having closed packed structure in which metal exhibits coordination number 12. For example, in case of sodium metal, if we take sodium metal, then there is crystal lattice of sodium, and the distance between the two neighboring sodium atoms has been found to be equal to 3.80 angstrom. This is the internuclear distance between two neighboring sodium atoms in sodium crystal lattice. Now, if we divide this distance by 2, then we get 1.90 angstrom. This is the metallic radii or crystal radii. This is the metallic radii or crystal radii of sodium metal. Thus, metallic radii may be defined as 1/2 of the distance of two metal atoms, adjacent metal atoms in a metallic lattice in which the metal has coordination number 12. The third one is covalent Wonderwall Radii. The third classification of atomic radii is Wonderwall Radii. It is known as Wonderwall Radii. Wonderwall Radii. Third classification of atomic radii is Wonderwall Radii. In case of non-metals, there are many solids which exist in the form of aggregates. In non-metals, there is covalent bond, but the neighboring atoms are bonded together by a weak bond which is known as van der Waals forces. Therefore, the van der Waals radii may be defined as 1/2 of the distance between the two neighboring atoms of adjacent molecules. If there are two neighboring molecules B2 and B2, and here the two neighboring atoms are B, then this distance, this distance is D, the distance between the two neighboring atoms which are not bonded directly is D, then D by 2 is known as van der Waals radii. This is known as van der Waals radii. B and B are bonded together by covalent bond. Here also B and B are bonded by covalent bond, but two adjacent molecules, the distance between the two neighboring atoms is d, then d by 2 is known as van der Waals radii. Next is ionic radii. Next, I shall define ionic radii. Ionic radii. In case of ionic crystals or ions, the distance between the nucleus of an ion and the point up to which the nucleus has its effect on electron clouds is known as ionic radii. Thus, we see that ionic radii may be defined as the distance between the nucleus of an ion and the point up to which the nucleus has its influence on electron clouds. This is known as ionic radii. So today I have discussed about atomic and ionic radii. Atomic radii cannot be measured directly. They are measured by indirect methods, by measuring internuclear distances or interionic distances. These distances are so small that it cannot be measured directly. These distances are measured by instrumental techniques such as X-ray diffraction, XRD technique, or electron diffraction methods. These are of the order of angstrom. Atomic radii can be classified into three types. First one is covalent radii in case of covalent molecules or non-metals. Second one is metallic radii in case of metallic crystals. This is also known as crystal radii. And third one is Wonderwall radii. If we compare Wonderwall radii with metallic radii or crystal radii, then Wonderwall radii are much larger than the crystal radii or metallic radii. This is due to fact that the binding forces are much stronger in case of metallic crystals than in van der Waals forces. So today I have discussed about atomic and ionic radii. If you have any query in this lecture, you can write in the comment box. Your feedback is required. If you have not subscribed my channel yet, please subscribe by pressing subscribe button. Thank you once again.